Good afternoon, and thank you for joining me here today. My name is Gabrielle Passick. I am a musician and librarian and will be discussing the wonders of the music ontology specification. Let's get started. What is music ontology? The music ontology specification is a metadata standard. According to the music ontology specification page, quote, provides main concepts and properties of describing music artists, albums, tracks, performances, arrangements, etc. on the semantic web, end quote. Inspired by both the timeline and event ontologies models, music ontology can be thought of as an encyclopedia of terms while allowing statements of performances including dates, times, formats, and file types. What is the purpose of music ontology? Music ontology serves many purposes, including addressing inconsistencies in the representation of music data. The University of Crete describes music ontology as, quote, a vocabulary for linking a wide range of music-related information through a democratic mechanism, end quote. The standard takes on a Wikipedia-style approach, allowing for collaborators to add, change, and manipulate data to best fit into the musical metadata standard. On the right, we have the music ontology object properties diagram, which we'll delve into on the structure and major elements slide. We will now address the history of the standard. Prior to the creation of the standard in 2006, there was not a standardized framework for music-related data, resulting in difficulties in areas of interoperability, partnerships, and incorporation of music metadata. This specification resolves the previous issues by providing structure for musical jargon, exportation of data, and continued collaboration between scholars, institutions, musicians, and librarians. The new data repository of the standard can be accessed via GitHub, as the original repository location at SourceForge has deprecated. What are the guiding principles and framework? Music ontology is based on three main concepts: classes, properties, and relationships. It uses OWL, or Web Ontology Language, for the RDF models. The objectives are to provide transparency, allow for an assortment of musical terminologies to be utilized in the record and diagram creations, as well as an ever-changing environment for the implementation of new terms, ideas, and information. Structure and major elements are next to be discussed. There is not a set amount of classes or properties. On the official music ontology page, there are 54 classes and 153 properties described. Relationships allow for full statements such as the Schubert Trout Quintet is performed by the Norwegian Chamber Orchestra, or of all three of Bruch's violin concertos, only the first concerto is performed. Classes describe content referring to the terms, genre, performer, instrument, etc. Properties include words such as has creator or has duration. To continue analyzing the specification structure, there are three levels of music ontology. Level 1 encompasses basic information such as class being CD, property, collaborated with, and individuals or relationship remix. Level 2 describes the music creation process with our next example, class being conductor, property, performance of, and individuals or relationship omitted. Level 3 focuses on event decomposition, with our last example of class being physical timeline, and property begins at date time. The individuals or relationship equals universal timeline. In the image presented on this slide, the collaborators used the OWL model to represent some of the top-level classes of music ontology. Classes are the keywords within the bubble, such as opus, composition, and sound. Properties are the has statements, such as has style or has product. Lastly, relationships include on timeline or uses instrument. We will now explore more RDF and OWL models from this specification. Most music ontology projects are RDF coded in HTML, RDF/Turtle, and JSON-LD. It is important to note which URIs are part of the musical collection for music-related resources of your choice in the namespace creation process. For our first example, we can see the music production workflow diagram from the Music Ontology official website. Keywords such as produced work, sound music artist, and published as are present in this diagram. On the next example showing code, this is the RDF version of Johann Sebastian Bach's Art of Fugue performance. The coding shows the instrumentation involved, year of performance, event time, along with other information that creates a complete music metadata record. On this slide, we have another example of the music ontology specification in an extended format. This diagram from isophonics.net combines music ontology with studio ontology framework. We can see the usage of the Ferber model and FOAF protocol. Our audience includes music technologists, digital humanists, music librarians, and sound engineers. There are a handful of challenges with the implementation of music ontology. Usability and training is time-consuming and complex. Metadata librarians, MLIS students, and musicologists may be the only populations that feel comfortable with the standard. Ensuring consistent data and formatting according to the properties and classes of the standard are other concerns. Paywalls and copyright laws behind the music-related objects also present challenges. Emerging musicians and composers may have certain restrictions on their works that information professionals must abide by. Librarians may not have the freedom to select a specific standard and may be limited to using MARC, which is restrictive. MARC does not fully represent the array of music terms, technologies, or artists. MARC would need more beta testing to acknowledge BIPOC musicians and their works along with non-Western music. Librarians can use music ontology to catalog music-related media into a uniform structure with the use of appropriate properties and classes, resulting in improved data integration and searchability within the library and its catalog. On the subject of interoperability, librarians can export music metadata into digital repositories and onto platforms such as YouTube or Spotify, along with sharing with other institutions. The interdepartmental collaborative efforts between librarians, music faculty, and digital humanists are necessary to continue production of music-related records, facilitating instruction, creation of LibGuides, and programming initiatives. Promoting research, outreach, and guidelines within music ontology will allow performers, students, and musicologists with access to music metadata for further discussion, education, and research. Before we conclude, I would like to share the resources used for this presentation, including musicology-related papers, metadata-related blogs, along with diagrams from musicontology.com. The Music Ontology specification continues to amplify music education, research, cataloging, and patron interest in the arts. While it is a lengthy process of understanding and implementing this specification, both music and academic communities will be able to devise a workflow which will benefit both communities in composing, performing, and instruction, along with continued research and accessibility of materials via online public access catalogs. Thank you for taking the time to learn more about music ontology. If you have any questions, please feel free to reach out to me on LinkedIn or via email gvp6@pitt.edu. Thank you.